Hi, in this video we are going to see about the solution of the number of NGOs problem which was given in POD on 9th January 2021. So let us quickly see the problem statement. An MNC has got a foundation which wants to provide seed fund for few non-governmental organizations NGO committed to improve education quality across the country. They make a call for this and circulate an online application. More than one member from the NGO can apply for the seed fund. A column in the online application asks for the number of applicants excluding himself. The short form for number of applicants is NOI here. Excluding himself applying for the seed fund from the NGO to which the applicant belongs. So now the question is, given m random values of NOA column of the online application taken from few applicants of k NGOs, write a code to find the maximum number of applicants from these k NGOs. So there are few examples given in the problem. Let us go through the examples and the explanation given, and then we will come to a conclusion how to approach for solving the problem. So the first input given is 5. The first line actually contains the number of NGOs from which the applicants are taken, right? That is in the input format. So first one contains the value of k, that is the number of NGOs from where the applicants are considered here, right? And totally 7 applicants are considered here. This is the value of m in the problem, and these are all the values what they have filled. Okay, the first person has filled 2, second person has 3, and so on, right? And the output is given as 17. How they got 17? Let us see the explanation. So when there are 5 NGOs and there are 7, we have to pick any 5 values for these NGOs, right? Actually, we are going to take a subset of the values. We have to take 5 out of 7 given values. That is the objective, right? And when we look at the different values, there are 3 unique values or 3 different values in this particular input, 1, 2, 3. Okay, so when you look at these 3 values, it is not possible that the person would have filled, these 3 persons will belong to the same NGO. What I mean here is, if let me say there is an NGO X and there are 3 persons from this NGO, ABC is applying for the seed fund, right? When A is filling, he will give the value of 2, B will give the value of 2, C will also give the value of 2, right? If they belong to the same NGO, then they will fill the same value only, right? But the same value is there doesn't mean that they belong to the same NGO. What I mean here is, there may be another one NGO Y where there are 3 people D, E, F. These 3 people are applying for the seed fund. Okay, they will also fill 2, 2, 2 only, right? So the point here is, if same value is filled by more than one person, there is a chance that both of them may belong to the same NGO, but not necessarily. Okay, for example, it may be from A and D. In this case, one of the value might have been taken from A, other one might have been taken from D. Then they belong to the different NGO. Otherwise, it may be like the value returned by A and the value returned by B. In that case, we will say that they belong to the same NGO. But the problem here wants you to find the maximum, right? So when you want to find the maximum number of possible things, then in certain cases, we have to consider that they have been returned by different applicants are from different NGOs, right? Particularly when it is larger values, we have to consider if there is a chance of eliminating a lesser value, a smaller value and a larger value, we have to give preference for eliminating the smaller value because we want to find the maximum thing, right? Okay, let us continue this particular example. So 3 values are taken. Totally we have to take 5 values. We have taken 3 values, 1, 2, 3. And now we have to take 2 more values. What is left over here is, when you look at this input, this 1 is taken already, 1, 3 is taken, 1, 2 is taken. What is left over is, there is a 1 and there are 3 3s. Okay, and you want 2 values to be taken. We do not prefer 1 because we want to maximize the output, right? So we are going to take 2 3s. In this case it works out. Let us see how we have to further refine. Okay, so the values that are taken here are 1, 2, 3 and 3 and 3. So when you add up these values, you will get 12. Okay, fine. But the point here is, they are writing excluding themselves. So if there are 5 entries, we have to add 5 also, because the NOVA column asks you to write the number of applicants from your NGO excluding yourself, right? So because of that particular point, we have to add 5 each one for each of the things. So the answer is 17 what we got. Okay, so let us move to the second example. In this example, there are 3 NGOs from where the applications are considered, and 6 applications are considered here, and the values are given like 233, 211, right? So let us look at the unique values first of all. When you take the unique values, it is 1, 2, 3, okay? There are 3 unique values and you want only 3 NGOs, right? So obviously, I am not going to take any other value from the remaining things. All the 3 can be eliminated. Totally there are 6 values. Remaining 1, 2, 3 can be eliminated now, right? When I add this, what I get is 6, but I have to add 1 of each for including the person who have returned us. So the answer will be 9. That's what is given here. Let me go to the next example, the third example. Here there are 6 NGOs from where the applicants are considered and 12 applicants are considered, right? 12 values are going to be here. And what is the output? That's what we have to see. The first step is you have to find how many unique values are here. There are 4 unique values, 1, 2, 3, 4. So 4 values are chosen. I have to take 2 more values, right? So when you have to take 2 more values, so let us do the previous thing and check whether this will work out. I have taken 1, 4, 1, 3, 1, 2 and 1, 1, right? Okay, now I want to take 2 more values, whether I can go for the maximum value, whether I can take this 3 and I can take this 2. That's what, because we want to maximize means always our tendency will be to take the bigger values. Whether this will work out, yes or no? No, because when you look at the values, there are 4 ones returned. Okay, when you look at the number of ones, there are 4 ones returned, right? When a person A, let me consider a person A, he is writing 1 means he belongs to a NGO X. Okay, if he writes 1 means there is only one another person from the NGO X who will write 1. Okay, others, okay, only 2 people will be from that particular NGO, right? There cannot be more than 2 people. When an applicant of an NGO writes 1, there will be only 1 more, right? Yeah. So these 2, let us assume that these 2 are belonging to the same NGO X. Then this one is from a different NGO. That's the point that we have to consider. This will be definitely from a different NGO, right? So we have to take this as a different one. Okay, let me say he belongs to another one NGO Y. Okay, then there is a chance that this person will also belong to the same NGO, right? So now I have to consider 1 more 1. That is because there are 4 ones. This is the logical reasoning required here. Okay, this problem is actually tricky. This is the logical reasoning required here. You have to consider the number not only based on maximizing but also based on the concept, that is how the value will be returned. That logical reasoning is also very important, right? So I have to include 2 ones. And let us look at the number of 2's returned. How many 2's are returned? Totally 5 2's are returned. Okay. When a person writes 2, then it means that totally there will be only 3 applicants from the particular NGO. There only 3 people will write from the same NGO. Only 3 people can write 2. Okay. So when there are 5 2's, there is a chance that they come from at least 2 NGOs, at least 2 NGOs. It may be the other possibilities, they may be from even 5 different NGOs, right? That is not the point here. But here the point that we have to understand is all the 5 cannot be from the same NGO. So they will be definitely from different NGOs. So I have to consider that also, right? My 1, 2, 3, 4, 5, 6. My 6 slots are filled now. So I have to eliminate this 3 and rest of the 2 and 1 and so on, right? Okay. So the value that I have to consider here, the 6 values I have to consider here is 1, 1, 2, 2, 3, 4. So when you add up this 1 plus 1, 2, 4, 6, 9, 13 and then 6 for including themselves. So the answer is 19. So let us look at the explanation. Here what is said is we need to take 6 values out of the 12 given values. Of course, first of all you find the different values that has to be taken 1, 2, 3, 4, and when you look at the number of ones, it is 4. For a value of 1, only 2 entries can be from the same NGO. That's what I was explaining. Therefore, one more 1, that is 2 ones have to be taken in this case. Similarly, when we look at the number of 2s, it is 5. Only 3 2s can be returned from people of same NGO. Yes. Therefore, we need to take one more 2, that is 2 2s in total. So, the values that are chosen are here. That's what I showed you, added up and add 6 more 4 including themselves. So, the total will be 19. The input format and output format is given, right. So, how I can view this problem is, so we have understood the problem. Let us come to formulating the steps that is involved for that. So, how I am going to view this problem is like an elimination problem. I am going to take the subset of the values, right. So, I have to eliminate few values which are not required for me, right. How I am going to eliminate? For that only we are going to formulate a thing. So, you see that least possible value, whether it can eliminate always? No, it does not always work. The last case we saw, we cannot eliminate a 1 or a 2. Though 3 was available, you cannot eliminate a 1 or a 2 because they have a reason, right. So, each the point that we have to emphasize also, each different value should belong to different NGO only. So, you have to decide the element to be eliminated, and how we can do is basically it's like a grouping. How we can group, that idea we have to bring in. So, how we can group is we have to consider that same value is returned by a person from same NGO, right. This point, that's what I explained you. So, if a value is same, there is a chance that it would have been returned from the same NGO. Sometimes, that's what, there is a chance, not always, right. And if the value written is I, then only I plus 1 person of the same NGO would have returned it. That's what. If a value is returned as 1, then 2 people only might have applied for the seed fund. If the value returned as 3, then only 4 people might have applied for the seed fund. If the value is 2, then only 3 people might have returned, okay, might have applied and might have returned. So, that particular concept we have to incorporate while doing the implementation. So, let me formulate an algorithm for this. The first step is read the input. There are 3 inputs that we have to read. Okay, the first one is going to be the number of NGOs, second one is going to be the number of NA values that are given, and third one is going to be the NA values, NOA values that are given. And then you are going to see the unique values, right? And I am giving a name for that. Unique underscore values will be the list in which unique NOA values are going to be stored, and I am going to sort it in ascending order. So, the least value will come as the first one, and for each element in the unique values, what you are going to do is, you are going to find out the number of entries that may be deleted. First of all, I am going to find out how many entries may be deleted. For that, let me take one example and show, that will be better. So, let me take a example what we were discussing and explain. So, if you are going to consider this one, 4, 3, okay, 3, and then 2, 2, 2, 2, 2, 1, 1, 1, 1. So, first I am going to find out how many values can be deleted, may be deleted or may not be deleted, but what I am trying to do is I am going to identify how many values can be deleted. Okay. So, when you look at the 4, there is only one entry of 4, I cannot delete it at all, right. So, I am going to form a dictionary in which I am going to say 4 cannot be deleted at all. So, 4 is the key and the value is 0, that indicates the number of entries that can be deleted, right. Okay, and when we look at 3, okay, how many 3s can be deleted is actually 1, okay, because when there are 2 3s, there is a chance that they belong, both of them belong to the same NGO, there is a chance, okay. And when you look at the number of 1s, there are totally 4 1s, okay. So, when there are 4 1s, there is no chance that all the 4 belongs to the same NGO, because there is a restriction, understanding, reasoning that only 2 people will write 1, if they belong to the same NGO. Only 2 people of the same NGO will write 1. Okay. So when you look at it, actually for 1, I cannot eliminate all the 4 or all the 3. I can eliminate only 2. Okay. And when I look at 2, okay, when I look at 2, actually there are 5 2's here. Okay, 3 people can be from the same NGO. These 3 people, let us assume that 3 people can be from the same NGO. If these 3 people belong to the same NGO, then other 2 should be from some other NGO, right? So for 2, it is going to be, how many I can eliminate is, I can eliminate 3 values. Okay, there are going to be 2 different possible NGOs. So I can, totally there are 5 values. So I can eliminate 3. I repeat again, how do I decide this is, there are 4 ones, okay, and when applicant writes 1, it means that there is one another person only from that particular NGO who is going to apply the applicant, right? And these applications are randomly chosen. So there is a chance that that person may also come, okay, but when I see here 4 values are there, the chances of 4 applicants belonging to the same NGO is not possible because the value they have written is 1. So only 2 people can or apply from the particular NGO, right? So only these 2 are belonging to one NGO, means this 2 should be from some other NGO. So there are going to be 2 NGOs basically. So I can eliminate only 2. Okay. When you look at 2, there are totally 5 entries, and for the value of 2, 3 persons may write it. 3 persons can write it, because if the value of value written is I plus 1 persons can be from the same NGO. That's the logic. Okay. So let us assume that these 3 belong to the one NGO, and obviously these 2 should be from some other NGO only, right? So the number of eliminations that I can make is definitely at least there should be 2 different NGOs. So I have to retain 2 values and I can eliminate. Here I am finding out how many can be deleted. Okay, so I can eliminate 3 2's. Okay, similarly look at the value of 3. When the value written is 3, 4 people can be there. Here there are only 2. There is a chance that both of them belong to the same NGO. So I can eliminate 1. Okay, and when you look at 4, there is only one value returned 4. So I have no chance of eliminating this one. So it is 0. Okay. So this I am going to form a dictionary like this. Okay, I am going to form a dictionary, or I am going to identify how many values can be deleted. That is the idea here. And then what I am going to do is I am going to, let me continue the algorithm. After identifying the number of elements that can be deleted for a particular value, I am going to do the elimination process starting from the minimum unique value, because you want to find the maximum value, maximum number of applicants. So you are going to start the elimination process of the value starting from the minimum unique value until excess values are removed. In the first case there were 7 and we wanted 5, so you had to remove only 2. Okay, so the stopping criteria is until the excess values are removed, you are going to repeat the process. And after removing the excess things, how we are going to print the values? You are going to take the sum of the elements. Let me name that as NOA values. Is the list, means sum of the elements in the NOA values and the length of the NOA values. Why should you add this length of the NOA values? Is because they are not including themselves while they are filling the application. So this is the algorithm. Let us see the implementation for this. Yeah, so the algorithm is written as comment here. So the first step says that read the input, right? So the first one is going to be the number of NGOs. So let me read the number of NGOs, and then next one is going to be the number of applicants. Okay, let it be equal to, you are reading it. And next one is going to be the NOA values, right? NOA values written by the applicants, and it is going to be a string. Okay, I am going to read it as a string, and it is in a single line, so I am going to use the split function. So the split function will return a list. So what I am going to do is I am going to convert each of the value in that particular list. So I have written a list comprehension. Okay, so for I'm going to take integer of the value for val and input dot split. Okay, so each of the value will come and then I will split it, and then you are going to find the unique values. How we are going to find unique values is I am going to use the concept of set because it will be easy, and I am going to convert back into a list because I want to sort it, right? So first of all, I am forming a set with NOA values. Obviously, when you put with duplicates in a set, duplicates will be removed, and then I am converting that back to a list, and I am going to sort it. I want it in ascending order only. So let me use the sort function. Okay, and then finished. Okay, now the unique applicants are available in the sorted order, in the ascending order. Now what you have to do is, for each element in the unique values, you are going to identify how many can be deleted. So I am going to have a dictionary. Okay, I am going to have a dictionary called as can be deleted. Okay, so what is the logic is, you have to retain the number of NGOs. Okay, for that I have to retain. For if they are from different NGOs, if the applicants are from 2 different NGOs, then I have to retain 2 different values. If I think that they can be from 3 different NGOs, if the logic says, then you have to retain 3 values. So first of all, find the possible number of NGOs from where the applicant might have applied, and then you will subtract it from the count, right? So let me say for val in unique NOA, right, I am going to take the values one by one from the unique NOA, and I am going to find out the possible. Okay, let me find out the unique. First of all, let me find out how many values are present in the original thing. Okay, okay, let me find out how many persons have applied for that particular thing, and from the same value, and then we can, so I think better we can have like number of occurrences. That will be more appropriate thing. Number of occurrences is equal to, I am going to find out how many times it actually appears in the NOA values, right? That is the name I have given, NOA values. So how can I find that is, you can use the count function. It is a list, so use the count function to find out how many times it has occurred, right? And then what we are going to do is, now we are going to find out how many possible NGOs are there. Okay, so if the number of occurrences mod, okay, mod, right, val plus 1 equal to 0. Okay, I will say why I am doing this. Number of occurrence mod val plus 1 is equal to 0. Then you will say possible NGOs is equal to number of occurrences divided by, okay, val plus 1, right? See, what did we do for the value of 1? There were 4 ones, right? 4 ones means 2. What we did was, it is possible that 2 people would have applied from the NGO, right? When a person writes 1, 2 applicants can be from the same NGO, right? So that's what is val plus 1. You have to add 1, and if it exactly divides, fine. You do the integer division. When there are 4 applicants for 1, you do an integer division, you will get 2. Okay, so the possible NGOs are 2. That's fine. But in the case of 2, what did we see? There were 5 values for 2. And you have to divide it by 3. When I say 5 integer division 3, I will get only 1, but actually it should be 2. For that only I am writing with a case. So in this case, possible will be number of occurrences, okay, val plus 1, right, and then you will say plus 1. Okay, this is for the case when there are going to be values which are not exactly divisible. And now we are going to say can be deleted. In this you are going to put the value, right? The value is equal to, you are going to say number of occurrences minus possible NGOs, right? Minus possible NGOs. This is how we are going to build the dictionary. Okay, so let us run the code and see what happens for our example. Yeah, so let us see the input what we have given. Sorry, so let me type it 6, 12 and then these values. Okay, okay, right. Okay, I think I have to type it again, or let me put it in a notepad and check. Okay, I don't know why it's happening. Okay, 6, 12 and let me copy this alone and give. Okay, yeah, so the problem is you have to count val. I missed that, so I was getting that error. So let me run again and see. Yeah, okay. Yeah, so I didn't print it. Let me print and see. Print can be deleted. Okay, so you see here 4 cannot be deleted because there is only one 4, and 3, as we saw, 1 can be deleted, and when you look at 2, 3 values can be deleted and 1, 2 can be deleted. So we have got what we want, right? And the next step that we have to do is we have got the dictionary with how many values can be deleted. Now we are going to do the elimination, right? So let me say how far we have to do is while let me say len of NOA values, right? While len of NOA values is greater than number of NGOs, we are going to do. How far we are going to do is when there are excess values. This is basically eliminating the excess values from the list. So while len of NOA values is greater than NGOs, we are going to eliminate. And how we are going to eliminate is, first of all, we will say whether it can be deleted and so on. So first, the first step is you have to take the least value from the unique thing. So let me say least is equal to unique NOA of 0. That because it is in sorted order, the first one will be the least. Okay, and we are checking whether this least value is going to be how many times it can be deleted. In case if it is going to be 0, there is a possibility that it can be 0. Then in that case, what I will do is I will remove from the list of unique NOAs and I will continue the process. I have nothing to do. Okay, if the least value cannot be deleted, if the least value cannot be deleted, that is, if can be deleted of least is equal to 0, then what we are going to do is we are just going to remove it from the list, and we are going to just okay, sorry, I think I have to give us unique unique NOA dot remove, I think. Yeah, of least. I have to remove the least value from the unique NOA and I have to continue my process. And the second case is if the can be deleted of the least value is equal to 1. When the deletion can be 1, then what we are going to do is we are going to remove it from the unique NOA, right? We are going to remove it, but we are not going to continue, right? This is the difference between the previous case and this case. Instead, what we are going to do is, we are going to decrement the value from the can be deleted also, okay? Then list minus equal to 1. You have to decrement this by 1. And one more thing that we have to do is, we have to remove from the, that is the purpose, isn't it? We have to remove from the NOA values list also. It should be removed from the NOA value list also, okay? So what we are doing here is, we are going to continue this process. While the length of the NOA values is greater than the number of NGOs, you are taking the least possible value from the unique NGO. If the number of times it can be deleted is 0, then you are going to remove it from the unique NOA and you are going to continue. So obviously the next value will come for the next time, okay? And if the can be deleted of least is 1, then in that case also we will remove it from the unique NOA. And this is common for all other cases as well as for 1. So only we are not continuing. What you will do is, you will decrement the can be deleted, because now we are going to delete it for 1 time. So you are going to decrement the value of can be deleted of least by 1, and then you are going to remove it from the NOA values. This is what you are going to do, right? Okay, and then after that the algorithm asks you to print the sum of the values, okay, sum of the NOA values and then the len of the NOA values, right? This is what is required. Let us run the code and see. So let us try for the same input. Yeah, you see that the value was 19, and let us see, okay, the value that I gave was for this and it is 19. Okay, so what I will do is, now I have kept the vprepl window also ready to check the code. Yeah, let me copy it and put it inside. Okay, so when I'm trying to execute, it is showing me that it doesn't match because I am printing this can be deleted also, right? So let me comment it and try to run the code. Yeah, I think now it would have run it. Okay. So of course this was a tricky problem which I prepared in November itself and waiting for the right time to give. I thought this is the right time that you might be already familiar with much of the algorithms. Thank you.